Hey, what's up guys? We're going to look at measuring the specific latent heat of a material. So specific latent heat, or the letter L, is used to represent that. And the definition of specific latent heat is the energy required to change the state of 1 kilogram of a substance. We know that there's 3 states of matter. We've got solids, liquids, and gases. And we have the changes of state. So going from a solid to a liquid is melting. Going from a liquid to a gas is boiling. If we go from a gas to a liquid, it's called condensing, and from a liquid to a solid, it's freezing. If we're melting something, we have to put energy in. If we're boiling something, we have to put energy in. And this is to increase the spacing of particles and to increase the potential energy that these particles have. When substances condense, energy is released, and when liquids freeze, energy is released because the spacing is reduced and the potential energy of these particles decreases. How much energy is required to melt or boil, or how much is given out through condensing or freezing, is given by this equation over here. That the energy is the mass multiplied by the latent heat. E is equal to the mass times the latent heat, which is given by L. And different materials have different latent heats of fusion, which is for melting and freezing, or vaporization, which is the latent heat of boiling and condensing. And scientists have to be able to measure the latent heat of materials. And so do you. You need to know this experiment for your exams. So let's have a look at how we can measure the latent heat of a material. This is the setup we're going to use, and we're going to measure the specific latent heat of ice. And we're going to look at the specific latent heat of fusion because we are melting the ice into water. So we've got a number of different bits of equipment here. We're going to need to use a mass balance to measure the mass of water that we melt. Really important that we use a mass balance to do this. We're going to need a power supply, and this power supply is going to supply electrical energy. And the electrical energy is going to be converted into thermal energy in the immersion heater. And the immersion heater is this black thing here, which is in the ice, and it's actually going to be used to melt the ice. So that supplies thermal energy. And that thermal energy is going to melt our ice. We need to know how much energy we're supplying from our power supply into this immersion heater and how much thermal energy is going into the ice. So we need to use a joule meter. And the joule meter measures how much energy is being supplied. We've got a few other bits of equipment. We're going to use some crushed ice, which means that the ice can get closer to the immersion heater than if we used ice cubes and we get less air gaps. We need a funnel to make sure that we capture all of the water. And we're going to use a beaker just to collect all of our melted water at the bottom. So let's have a look at how we're going to do this experiment. We need to consider the equation. The energy required to change the state of a substance is given by the mass multiplied by the specific latent heat. And as I mentioned before, we're looking at the latent heat of fusion because we are melting ice into water. I want to know the latent heat of fusion of water. So I'm going to rearrange this equation where L is equal to E over M. So the latent heat of fusion of ice is given by the energy required to melt the ice divided by the mass of ice or water that has melted. So I simply need to make 2 measurements, the energy and the mass. And when I do energy divided by mass, I get my latent heat. So it's very, very simple. So step 1, we connect our power supply to the joule meter and to our immersion heater. This is so that when we turn our power supply on, the joule meter will measure how much energy we are supplying to the immersion heater, and then the immersion heater will convert the electrical energy into thermal energy, which is going to be used to melt our ice. Step 2, we're going to use some crushed ice and we're going to place it in a funnel above a beaker. Step 3, we're then going to place the immersion heater inside that crushed ice. And then we're going to turn the power supply on and turn that immersion heater on for maybe 15 minutes. You could do longer or even shorter, just enough time to melt a substantial amount of the ice into water. Step 4, once we're happy with the amount of water or ice that we've melted, we're going to turn the heater off and we're going to record the energy supplied using the joule meter. Once we've recorded that, we're going to take our water that's been melted and we're going to measure how much water has been melted using our mass balance. And then we've just got one final step. we go back to our equation that the latent heat is the energy that we have supplied divided by the mass of water that has been melted. And it's that simple. That simple experiment gives you the latent heat of fusion of ice. So just to summarize, the latent heat is the amount of energy required to change the state of 1 kilogram of a substance. And different substances have different latent heats of fusion, which is for melting or freezing, and vaporization, which is for boiling and for condensing. And scientists have to be able to measure it. And this experiment is an example of one of those ways. So if you're going to look at the latent heat of fusion of ice, you connect your power supply to the joule meter and the immersion heater. You then crush some ice and put it in a funnel. You put your immersion heater into that ice, and then you melt the ice. You record how much energy on a joule meter. You record the mass on a mass balance. Then you use this equation. The latent heat is the energy supplied divided by the mass. And that is it. It's really simple. Thanks for listening. See you all soon.